Is it streaming? Let me check my phone. Check if the stream is working. Let's see. Check if the stream is working. Okay, it's live. Alright, we're gonna do arrays and strings of the medium playlist. Okay, so this is the playlist that I actually practice the most. I do the easy one just a little bit, but this one is my bread and butter. Okay, so first off we have threesome. This problem is like burned into my memory. This one especially. I'll explain it real quick. Basically, when you're trying to find three numbers that sum to 0 and you gotta find only unique ones, first step is pretty obvious. You want to sort it. So you can use some approach from there. So -1, -1, 0, 1, 2, -4 is all the way at the start. 4, so you have a hold pointer. So this is like, so instead of having 3 pointers moving around, what you want to do is go through the values with a hold pointer, a small pointer, and a large pointer. L, S, H. So the hold pointer just goes from 1 to n. 1 to n. -2. This one goes from h to n. H to end. And this one actually h to left, I guess. The large pointer. H to L. And this one goes from the end all the way to the small pointer. So what does this look like? You have your hold pointer. So one of our values we're going to say is going to be -4. So if one of our values is -4, what do these other two pointers have to be? So small and large. So what is the sum of h plus whatever, like array of h plus array at small plus array at large? So the hold pointer means we assume this value is in our triplet. So this sum right now is -4, -1, and 2, so that's -3. So we need it to be larger. So in case that we need it to be larger, what do we want to move? Do we want to move our small pointer up, or do we want to move our large pointer down? We want to move small pointer up. So you move the small pointer up, it goes from -1 to -1, still -3, then 0. So the sum is -3, -3, and then -2, and then you keep on moving it up to -1, but it never reaches 0, so small goes all the way to -1, but then small can't equal large, otherwise we're just repeating a value. So now you move your h pointer and continue that same process. Why do we move the h pointer? Is because we want to consider every single value in for a triplet. So we assume maybe this one's it, no, maybe this one's in our triplet, maybe this one's in our triplet, so on and so forth. And another thing is when you're moving the hold value, you want to move it twice when you see that it's equal to a previous value. So -1, -1, we don't want to get duplicates. So a duplicate we could get is -1, 0, 1. And then we move our hold pointer up, and we can still get -1, 0, 1. But again, this is like a repeating duplicate. Even if it's a different -1, we don't want to include it again because it looks the same. So we just need to make sure our hold pointer is always unique. So skip duplicates. And since it's sorted, this is easy. Make sure it's not the previous one. It's not equal to previous value. Okay, that's the whole solution. Pretty simple. So first off, arrays dot sort nums. Then for let's make our output array. That's the first thing we should do. Find where our output is. Okay, for int I is equal to 0, I is less than nums dot length I plus plus, and let's define length. So we want it equal to length minus 2, less than or equal to length minus 2. Why? Because we'll never have the hold value at this index or this index. Why? Because there's no values for left and right. So the last index it can be at is 2 from the back. So that's why I do length instead of less than length. You do less of length minus 2. And this one's pretty easy. First off, if I is not equal to 0 and nums at I is double equal to nums at I minus 1. Actually, let's call it H because that's what we used in our example. So hold pointer, hold pointer, hold pointer, H, nums at I is double equal to nums at I, H minus 1, just continue. So skip this value. Okay, what do we do next? Next, we want to define our left and right. So instead of small and large, actually we could do small and large. Small is equal to small index, small int is equal to 0, and large int is equal to length minus 1. So while, and I guess the sum is something we want as well. Int sum is equal to nums at mid plus nums at small plus nums at large int. Not mid, H. Hold. So yeah, replace H by hold. So it's the value that we hold at. And this is kind of a left-right pointer approach because we want to continue. Even if we find a solution, we want to continue. So while our small int is less than large int, maybe it'd be better to use left and right then, but it's fine. We can calculate the sum. And then we say if sum is equal to 0, we have a winner. Else if sum is greater than 0, we have too big. Move large int down. Large int minus minus. Else this is sum is less than 0, too small. Move small int up. So this is the index of our small value and our large value, but it's easier to think of this with left-right pointers. So output.add arrays.as list. What is it? What do we want to add? We want the actual value. So nums at hold, nums at small int, and nums at large int. Great. Now, the same way how we want to make sure that the hold value isn't duplicated. We want to make sure the small and large isn't duplicated. So we want, what if we had 0, 0, 1, 1? Then we'll get multiple -1, 0, 1 because these values don't find unique values yet afterwards. So after you find a valid solution, what do you want to do? You want to iterate the pointers until they're at a new value. Small int is less than large int, and nums at small int is double equal to nums plus 1. And the same thing for the large index. So again, left, right pointers would be a lot better naming wise, because it's more clear to think about. It's more easy to think about because it's like a familiar concept, but it's the same thing, small index and large index. Minus. Yep. After everything's said and done, return output. Alright, run. Oh yeah. Okay, so I got a duplicate. Zero, negative 1, 1. Oh, I see what the issue is. wait, so you do negative 1, go back, see that negative 1 is equal to the previous one, continue, plus, no, that's fine. Alright, let's look at the sorted result. Removing these values. Okay, first one it finds is negative 1, and 2. That's fine. Next one it finds is negative 1, 0, 1. That's also fine. But it should skip the second negative 1, which it's not doing. No, small int is equal to hold plus 1. That's the issue. Because right now we are always starting from 0. No, the small index should be after the hold. Alright, that should fix it. Time limit exceeded. Okay. I see. Where did it get exceeded from? We're doing an infinite loop somewhere. Nums hold, nums continue. Okay, so nothing here would cause it. It's just this while loop probably. If sum is equal to 0, erase or add. Plus, large int minus. Small int is equal to small int plus 1. Yeah. Sure, we could just print it out and see where it gets stuck. Alright, indexes are 1 and 5. Let's bring an example here. Okay, so 1 and 5 is fine. Then 2 and 5. Oh, these are the hold. So hold, small, and then large was all the way over here. 1 and 5. It doesn't find a match. 2 and 5, 3 and 5, 4 and 5. 2 and 5. So this means it's over here. 2 and 5. Finds a match. 3 and 4. That's another match. It could be one of these while loops, honestly. That's what it looks like. So we don't iterate those. Still time limit exceeded. Shoo, bruh. Large in minus. Yeah, okay, so this is pretty annoying because they're not even showing me the full logs. Oh yeah, okay, so this is the issue. While this continue. Okay, I think I was like changing some code from before and didn't change that back. That's why they weren't showing the logs, because it's stuck in that while loop. Alright, great. It's working now. Dang, see, that's what you ask like a recruiter. You're like, you see something wrong? They're like, shouldn't this be an if case? And you're like, ah, shoot. Output limit exceeded. Oh, that's just because I'm printing. See, this is like some weird stuff with Java. See, now it's accepted. Yeah, so I guess they don't let you print out everything if there's too many values. That's cool. That's cool. Submit. Done. Set matrix to zeros. Set matrix zeros Leetcode. How do you stay consistent early on with your internship career? Okay, I was pretty trash at Leetcode. Let me respond to this guy. Actually, you could just hear me. Yeah, I was trash at Leetcode. Like, honestly, so trash. So what I did was I made YouTube videos because somebody said if you can explain it, you really understand the problem. So just make YouTube videos of you explaining problems. Like one. Two. Whoa, trippy. Video with the stream. Yeah, just find something to keep you accountable. Like, if I mess up in any of these problems, I'm not going to delete the videos. And some recruiter can even look at this and be like, wow, he's so trash at coding. but that's okay, you know. Like it forces me to like actually think about the solution, because if I look at the answers here, like what's it? I don't look at the answers by default, but if I was somebody who did look at the answers when I'm doing Leetcode problems, like a recruiter would probably see that and be like, "Oh, this guy is trash. He just jumps to answers." So it forces you to like really like kind of work hard on solving problems instead of just doing the cheat code. And if you explain it, you really understand it. Okay, so you must do it in place. If an element is 0, set its entire row and column to zeros. Okay. I do remember this. Like whenever I saw this problem, the first thing I was thinking was hash set of rows that should be 0, and a hash set of columns that, it doesn't even have to be, it could just be like a list, honestly. Anything to store like an array of values. But since they say in place, what you realize is, hey, that first row is a list and that first column is a list. So instead of doing all of this, we say first row is now this list of rows that should be 0, and first column is equal to list of columns that should be 0. And the one caveat is, if you use this to store what row should be 0, you don't know if the first row is 0. So you need, along with this, you need a boolean is first row zeros, and boolean, actually I guess should is better. Should first row 0 and should first col 0. So should first row and first column 0 out. That's pretty simple. Basically, like you store this, so x, this should be a 0, this should be a 0. Honestly, do you need the booleans? Because what if you just stored it as like, you can store it as like, since it's an int array, you can't really store it as something that's not an int. So there's always going to be some edge case that catches you. So you could just store these x's or zeros. So let's just say x is equal to 0, because I was saying maybe use integer on max value, because but then somebody might actually have that in their array, so that you don't have to have these two booleans. But I think you have to have these either way. The way it works. Okay. But yeah, let's make this very simple solution. These are both false initially. And we need a double for loop, so int r length is equal to matrix dot length, int c length is equal to matrix 0 dot length. So if row is equal to 0 and matrix row column is double equal to 0, then we know that first this should be true. Same thing with the first column being 0. Let me open up the stream to see if there's any more messages. Okay, thank you. These are just referrals. Okay, send me your resume. Wait, didn't I do your resume? Send me your resume on LinkedIn. Yeah, everyone thinks their resume is stacked, and you know, honestly, yours might be. But bro, trust me, there's always things you can improve about your resume. I do so many resume critiques. Some people, I made a LinkedIn post about it too. One guy came in with a pretty good resume. Other guy came in with a not so good resume, but either way, there's always things you can improve. It's like a resume is like, you gotta be like super detail oriented, because it's always one page and you have to like stand out in a game of inches. And half the time your resume is not gonna even be looked at, just because there's so many applications. They can't look at all the resumes, right? So this is for these special cases. special case row that columns that are storing. Put my phone up so I can see the messages. Okay, sweet. If matrix row column is double equal to 0, then we actually want to store it in our first row and column. So matrix rows 0 double equal to 0, and matrix 0 column is double equal to 0. Not double equal, single equals. In yeah, another thing is I'll show you like basically what I do on LinkedIn. What you want to do is go on jobs, United States. I search for Android engineer, but you can just search for software. Entry level and date posted last 24 hours. And I'll tell you like what are the good jobs and what are the bad jobs to apply to. So this is a pretty good job, but it was reposted 6 hours ago. So should you bother applying to it? Probably not. If it's reposted and over 100 people already applied, what's the point, right? 17 hours ago. See, this is a better job because it wasn't reposted. When it's reposted, that means they've already tried to get applicants and they want even more applicants. This is a good job to apply to. This is a good job. But yeah, even these jobs, like 13 hours and 100 people have applied. And it says over 100 because it doesn't tell you anymore. Before, it would be like, I think it used to tell you more information. I don't know if LinkedIn's hiding that somewhere. Probably not under span, honestly, but maybe there's like somebody who can make a nice LinkedIn tool that will show us the actual value, because hopefully they're not completely hiding it. That would suck. Also, another good way is just go to the tech hotspot. So that's California and the United States. Ignore like all these jobs that are like that post too much. Like if this Epic company posts too much, this jobs via Dice, that's a recruitment agency. They post too much. Look at this. This looks like a real company, but it's reposted. And you can still apply to reposted ones, but those aren't the ones that you're looking for. You're looking for like usually a small startup or something a little bit more niche. Liquid AI, look at that. 12 minutes ago, 24 applicants. See, just like that, easy apply. I'm not even gonna look at the job description just because if I can get my resume in there, I'm good. Blockchain, 3 years, of course. So these questions will automatically filter you out. And some people tell the truth on this. I hate to say it. I play the game. I just sometimes lie. So I won't stretch too much. I'll say, oh, I have 2 years experience with blockchain. I could learn enough before the interview, you know. Let's see. Great. And if you ever like make a business on LinkedIn and go to their jobs portal, you can see like how other things work. Like how some people, you get filtered into certain groups like good match, okay match, or not a great match at all. Yeah, I could look at your resume real quick, honestly. Okay, so right off the bat, you're using a font that's way too fancy. So you want to make it so it's extremely readable. So if you're using stuff like this, it's kind of cancer to read. You want it so it's like they can look at it and immediately see it. So if you're reading this and you see something like this, some recruiters might get pissed off and just throw your resume away just because, oh shit, actually you might not want me sharing your resume publicly. My bad, bro. My bad. Oh yeah, here's my open resume. Here, I'll send you a template and I'll send you the LinkedIn post I made. So I use Calibri as a font just because it's dumb. It's really dumb, but stuff like that helps. I'll send that, and I'll send you a LinkedIn post I made on resumes. Boom, 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 boom. Oh shoot, my battery's low. Wait, my charger's right here. Okay. Okay, sweet. Oh, sweet, I can show the resume. Okay. Dude, did I not make a post about this? How to get a tech job? No, that's not it. Oh yeah, here. Here, I'll send you this basic critique as well. I can show on LinkedIn. All right. Let's rip through your resume. So, we'll just do this for fun. Take a break from the code. Wait. Should I finish this problem? Let me finish this problem and then I'll go through it real quick. So after we're done this, you want another for loop for the first row. C is less than C length, C++. If matrix 0 So this is going through that first row, finding the zeros and then zeroing out that column. And then it's kind of like the inverse when you're going the other way. So now we want row is equal to 0. No, this is the first column, my bad. So no. This is the first row because we have 0. So we're going through that first row. Here we want row to be going through all the rows we have. Oh, my bad. And we want to go through the first column. So this is that first column right here. And then you iterate through and make all of those zeros. Okay, so this is 0 out the verticals. This is the 0 out the horizontals. And we have now two if cases that we have. If should 0 first row for int I is equal to print and again we have like the inverse the other way. Okay, see what that gives us. Okay, that's wrong, but actually let's just finish your review real quick. Then we can look at this. So right off the bat, the font's pretty bad. Some companies will actually disqualify you based on the year you graduate. Is this guy watching? Alright, hopefully you're watching, otherwise you can just watch it back later. You there? Okay, whatever. You can watch it over again. So some companies will automatically disqualify you based on the year you're graduating. A funny story is when I applied to SeatGeek, I got auto-rejected because they wanted only like seniors or juniors, like people who were going to graduate soon. So what I did instead was I just lied about my graduation year and applied with a different email, and I actually got the internship. And then when they wanted me to join full time, they're like, "Oh, you're graduating soon, right?" I was like, "Nah, I lied." But you know, you gotta do what you gotta do. So right off the bat, let's look at your first experience. Yeah, see, like this stuff, like it's way too fancy. You gotta just dumb it down to like the font I showed you. Something like this. Like, look how easy this is to read. You just read it, you're like, oh, nice and simple. Yours is too fancy. I feel like people are throwing out your resume before they look at it, which is sad, but it happens, man. I'm telling you. So I don't know what quick is. Is that a language? Oh, it's like a tool. Framework. Oh, that's pretty cool. So yeah, you actually have a pretty good experience here because you can just apply to find companies that use Quick because it seems pretty niche. So right off, your first resume point, design features for vicinity using blah, 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 optimizing performance and scalability. This tells me nothing about what you did. Your first resume point should always be something generic that gives you an overview of the role. That's the LinkedIn post I sent you. So developer on Robinhood app on the account security team, implementing features to mitigate fraud. Developer on the chat team, building on-command related microservices with blah, 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 blah. Developer on the SeatGeek app, using this, blah, blah, blah. So this was just focusing on the tools I was using and not exactly what I was doing. But the point is, your first point should give the reader context of what the other point should be. And the other points should be very specific features that you implemented. So if you said design features for vicinity, you're miss out on a lot of specificity. Like, what is vicinity? You're using this, but how do you improve performance and scalability by 37%? There's no context given. So right now, I read this and I'm like, okay, so he used some tools and he made up some metrics, if I'm being honest. Architected and implemented cloud infrastructure. Okay, so what does cloud infrastructure mean? What did this cloud infrastructure do exactly? So what you want to show with your resume points is what is the impact of that cloud infrastructure? Was that cloud infrastructure used for routing, command logic, for whatever? Say that then. It doesn't always have to be exactly one line. People get hung up on this. It just has to be concise. Integrate ML models with graph databases. So again, this is using very like open-ended wording. Deliver personalized data-driven insights that optimize user interactions. So it sounds very ChatGPT-ish because it doesn't like exactly say what you did. What's a personalized data-driven insight? You can give us examples. You can say deliver personalized data-driven insights, including customer, whatever, blah, 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 blah. So this is like going to be a problem with a lot of your resume points. I gave you my resume so you can use it as a template, and also you can just see how I structure my points to be very specific. So implemented passwordless login. So that's what I did. But I didn't just stop at that. Via passkeys, using credential manager to add secure login methods. Worked with Android library developers to latest alpha of using the credential manager library. Like, I specifically said what libraries I use just to like be very, very specific. Now, this is a good experience section, except that you need to be specific. You need to be extremely specific. And let me tell you, having that first point be an overview of the role actually helps you out because now you have more points. So 3 points is kind of low. What I usually do is like have that overview point and then the 3 main features that I worked on. Oh yeah, okay. So again, like that's basically the biggest issue with your resume is you need to show how specific you are. So if you did something that's kind of hard or impressive, you're gonna know exactly how it works. You're gonna know I use this library, I use I use Kafka here, use Kubernetes here, and you're gonna be able to explain it well. So that's gonna take practice, like just being able to form resume points. Over here, don't put HTML, CSS here. what's important is not HTML or CSS. It's the fact that you use React. So React, you use JSX. You're probably using like Tailwind or something, or some design library, right? Most of the time, you're not working directly with React, or when you're not working directly with HTML and CSS. When you're working with React, you're working with JSX. So just cut these 2 points out. You could say React and then like some state management library. Like there's Zustrand and there's Redux that a lot of people use. So try it. Even call up your old employer and be like, hey, what do we use for state management? Just remove this point. Ooh, structuring projects. Yeah. Okay, so you're not a project manager. You're trying to be a software engineer. This is a very project manager point. And again, it doesn't like it doesn't show impact because you're not talking about what the project was. You're not talking about what deadlines there were. You're not talking about what the team was that you're constructing the model for. So if I was a project manager, I would say constructed a waterfall model structuring projects for the delivery service team. Was it reaching, what do you call those? Sprints. So generating sprint deadlines. And then you talk about what, if you're a project manager, you want to talk about what the project resulted in. Releasing this, and this new feature. So yeah, like I've been in the same position. Like, I thought my resume, I was like, oh, this is hot shit, bro. And then somebody else reads it and like they just rip it apart. They're like, oh, this just means nothing. But kudos to you because you're ballsy enough to like let me rip it apart. And you'll definitely do well if you keep that mentality, because the more people that rip you apart, you can be like, oh, okay, I'm messing this up, and you can fix it, which is the important part. So even today, like I still have people review my resume and see what they say. Like I reviewed my resume just now and I'm like, oh shoot, I should fix this point or whatever. But it's just generally good. So I'm fine with it. Great, you're linking your projects. Okay. So it looks like you're really going for okay, first of all, move your education to the bottom. It's not that important. So what recruiters really want to see is actually this additional information right away. And you actually have your additional information like formatted extremely well. This is exactly how I do it. But yours is even more impressive because you have way more stuff that you know. Ditch HTML, CSS, add in TypeScript. If you don't know TypeScript, you do know TypeScript because you know JavaScript. And TypeScript is just kind of like Java types with JavaScript. You just add types. It's easy. Ditch HTML, CSS. I probably have it too, but I just throw it at the very end. Yeah, I have it throw it at the very end just because I want to fill it up. This is good. Why don't you have React in this list? You should have React. You shouldn't have Figma. I mean, unless you want to be a designer, like screw Figma. Yeah, generally pretty good. And move all of this up here and move the education section down. So I sent you a critique. I'll also send you like a resume guide that I give people. Shit, it's kind of weird. I'll send it to you later. I don't want people looking through like my folders. But good on you, man. You were good enough to put it up there. What you want to focus on is like the Leetcode video, the LinkedIn video that I sent you. Overview, specificity, and impact. So rewrite all your resume points. No exaggeration there. Just rewrite all of them. Use the template I gave you, and you'll be like in a much better spot. I promise you. Do cover letters matter? Don't write a cover letter unless it's super generic and you can send it to everybody. And your cover letter is way too long. So my cover letter is probably like this much or less. Just because the person reading your cover letter just wants a quick scan. So what you do is you basically pitch yourself. So if you know what a sales pitch is, you pitch yourself extremely hard why you're a good fit for that role. And most people don't read cover letters. I just did it because I have that pitch saved from when I applied to YC companies. So I was like, I'll just turn it into a cover letter. But overall, you know, I think you're doing fine, man. Kudos to you. Everyone has a bad resume. You're in Laurier and you're getting internships, so like you're doing extremely well. I know kids in Waterloo not getting internships. If I have to look at your experience, it looks like you're a pretty full stack engineer with a back end bias. So apply for a whole bunch of back end roles. Find companies that use specific technologies that you know, because you'll be a good fit for them. Like Kubernetes, go find companies you know using Kubernetes. There's like, I mean, a lot of companies use it. What else? Yeah, basically any cloud roles, go apply to them. Because you know AWS, you know Kubernetes. I don't know what Plumi is. Yeah, that's probably not as popular. Apply to DevOps role if you have DevOps experience. Apply to ML roles since you have ML experience. Apply to AI roles and really focus on this part of your resume so you even move it up. Oh, this is sick. This is sick. Yeah, dude, I'm trying to get into AI right now. That's sick. Okay, but you're a smart guy. You'll do fine, man. Don't take my feedback too hard. And you're young. You're like, what, 3 years younger than me? That's very impressive. Very, very impressive. Whoa. Yeah, 3 years younger. Okay, but you're good, buddy. Fix that all up, and then send me your resume again, and I'll review it again. Okay, back to that problem. So a good way to see the current state is anytime. See, I'll get it anytime, man. Proving attitude. Okay. All right. Let's see the state of the array after. Okay, let's run that. Um, 0, 1, 2, 0. Okay, okay. And let's also print out is first call 0. Boom, boom. First call row true. First call true. Oh yeah, this should be true. What the heck? All right. Now let's run it. True and true. And whatever we did with our loop didn't work. Oh, I see. I see. Okay, so when you iterate from 0, then you see, hey, this whole first row is 0, and you turn it to 0. So you always want to start at 1. That way you avoid the issues. So for int c is equal to 1, for int row is equal to 1, then set the zeros. So we don't want to touch these when we're setting the rest of the zeros. I can explain to you what was happening before. What was happening before was we would go to this 0, we'd be like, oh, it's a 0, and we set all the zeros. But what we wanted to do was not look at the values. This L right here, this kind of 90-degree bent L, stores what value should be 0. So we should only look at these ones and be like, should this be 0? No, continue. Should this be 0? No, continue. Kind of like that. So if this detects, hey, this is 0, it will 0 out this entire column. If this detects, hey, this is 0, it will 0 out this entire column. But it wouldn't touch the first row and first column until we use our variables. So great, we got that working. All right, group anagrams. Okay, given an array of strings, group the anagrams together. You can return the answer in any order. So how do you check if a value is an anagram? Okay. Shoot. So for this problem, we want to group the anagrams. So what do anagrams have in common? What do they all have in common? They have the same occurrence of letters for each. So do you know what would be cool? You can actually calculate a score. So if it's A, A, B, B, C, C, then we could assign values to each letter. So A is 1, B is 2, C is 3, but that wouldn't work because what if we have like more letters and then it doesn't really work out because you could always like sum up weirdly. So what you should do is use the actual anagram, like the sorted one, because if you sort it, it's always the same. So if you have eat or 8, if you sort it, it's always AET. Yeah, so that's how you can check which, like if two values are the same anagram, you should sort them. And to group them, we want some data structure with some key and some list of string. And this key should be common to all anagrams. So it could be the sorted string, AET. So we can just make a map. From there, it's pretty easy. This for and we need a map. Okay, so with that sorted S as the key, we add them to a list of strings, and what we need to do at the end is for string key in map.keyset, hash map.value. So we could just actually do this for list of string group in map.values, output.add group, turn output. Okay, third question done. We have 4 more. Yeah. Okay, I'm gonna do a water break and then get back to it. Okay, find the length of the longest substring without repeating characters. Let's define this substring. So what is a substring? It's a continuous block from the string. So if you have A, B, C, you can have substrings of A, you can have A, B, C, B, B, C. Let's just try a short one, A, B, C. And you can also have C. Those are all the substrings you can have. And what you can notice is it's kind of like a common theme to have a left-right pointer approach. See, so you can have your left pointer here, right pointer moves up, and then you have A, so your left and right pointer start off initially at the same point. A, AB, and ABC, you can have that with the left pointer not moving. You move the left pointer up, you have B and BC. B, move the right pointer up, BC. So B, BC, and then move the left pointer up, and you have C. So now, hey, you just found a way to go find all substrings. Found a way. And what is that? That's a left-right pointer approach where you open the right pointer and you close it, open the left pointer, close it, stuff like that. And with this, you can get all substrings. And then if you want a really ugly solution, you could just say, let me find, now that you have all substrings, find all with unique, find the longest with unique values. So this is actually a sliding window. So you can see how it slides open and it slides closed. The way that we found the substrings, that's called sliding window. Now, while you're sliding the window, is there something you can do to store what characters you've already seen? Yes, you can have a hash set of characters that you've seen so far. So that every time you see a new character, if you know you've seen it, you know you have to close the window until it's a unique character. So let's take this example, for instance. Let me increase the font size. So our left pointer is at A, our right pointer is at B. That's unique. So actually, and let's have our scene list. So our scene list initially is just A, because they both start at A. Then you move to B, add B. Then you move to C, add C. Then you move to A again, which is a new A, and you say, hey, we've already seen the A, we need to close our left pointer. So we move this left pointer to B, pop this out, and then we say, hey, we no longer see A, now we can add the right pointer, which is A. So now our value that we're looking at is BCA. So these two are indexes, even though I'm showing the value. And this list is a list of values. So now that you guys got a general idea of how to do this problem, I can code it up real quick. So char array R is equal to new. I call it car because it's the char car array. Yeah. Alright, and then we want int max length is equal to 0. And we want our left and right pointers. They both start at 0. And we want to do this for all substrings. So while left is less than length, which is equal to car.length. Why do we want it till the end? Because we want to check every single substring. Now you're going to say something like, oh, Father, there's an optimization you do with this left right pointer stuff. Hey, if we find something that's like 10 characters long and we only have 9 characters left, we don't need to check those 9 characters because we know that it can't be a subarray larger, right? So if you have something like A, B, C, D, E, F, G, H, I, J, K, L, M, A, B, C, D. So you're saying, hey, we found 10 characters. This character, this new A is already in our list, but there's only 4 characters remaining. That means we've already found the longest subarray. And I'm going to tell you a great piece of advice, which is keep it simple. You can talk about optimizations after you solve the problem. If you start trying to optimize right away, like you end up screwing yourself over. One time I had an interview I really wanted. It was only 30 minutes. I started doing this problem and I'm like, okay, I know the easy solution. Let me try and find a better one. And I was like looking for a solution that wasn't there because there was only a brute force solution to this problem. It was ridiculous. And the interviewer, his expectations were low. It was a 30-minute interview, but I was trying to do some dynamic programming, trying to think of a better way. And it turns out the easy way was the best way. So it's not optimized. It's not optimized. You can talk about it after, but people don't even expect you to optimize like that. This is like if you're making a super high performance system, you could optimize like that, but otherwise, what's the point? Okay. If we need a hash of all the characters we've seen. If Otherwise, what do we want to do? We want to do scene.add, right? Why do we do +1? See, we don't need to because we do right ++. So that +1 is negated. Second condition, we don't want to overflow. So what is this step? This is closing the window. This is opening the window. Oh, damn. Oh, while left is less than length. No, left is less than right. Okay, yeah, so I was thinking about like left, right pointers on either side. This is a sliding window, so while left is less than length. Output 4. That's strange. It passed the first two. PW. So it adds. Let's actually add print lines so we can see what it's adding and removing. Throw it in there. Quickly we can see what's going wrong. Adding P, left 0, right 1. Yeah. P, adding W, removing P. PWW. So PW, you should remove W as well. So PW, adding W, removing P. Oh, so this is while. Oh my gosh, so while. So you want to keep on removing it until you remove the character that's causing the problem. Duh. I even said that up here, but it's okay, it happens. That's why you should always explain your code first, because if you have some backing of the explanation, you're better off usually. See, look at that. I removed my print statements and it beats way more. So time complexity on Leetcode doesn't really matter. Unless you're like a competitive programmer, and in that case you're not using Java, you're using C++. Okay, let's see if I can finish this before I have to go for prayer. Oh yeah, this is an interesting problem. I remember this problem because when you start Leetcode, you just start looking at answers. Like when you're really young, you're just like, because you have no idea how to do this. I was extremely proud of this one because I got it like all by myself. Like no advice, nothing. So the way to think about this problem is, I made a video on this as well on my YouTube channel a long time ago, is how is a palindrome formed? So a palindrome is formed by having the same characters, was it same backwards and forwards, right? So some examples are race car. Now, if you think about a two-pointer approach, you can start, if it was something like RACEDAR, you could start on either pointer and be like, oh, these are both R's, and then work your way in. But it's kind of, you're not guaranteed it's going to be a palindrome just because you have instances where like you have a D and a C here. So all that checking you did was pointless. Now, what if you started from the middle? So your left-right pointer started at E. So then you move your right pointer down to C, and you know this, you know E is a valid palindrome by itself. Then you just move your pointers one down. So race car, and you know, hey, CEC, that's also a valid palindrome. That way, you're not working with like instances of invalid palindromes, or you just don't know because you're starting from the end. If you start from the middle and work your way out, you can check each step of the way that's a valid palindrome. And that's basically the solution. So it's a left-right pointer approach where you just open a window, because like that's like the idea people give, like sliding windows. You know those two windows, you slide one, open the other. Opening window is just like, or opening curtains, I guess. You open the curtain because the middle is going to be a palindrome because it's a single character. If the next two are the same, it's a palindrome, and you should open further, open further, open further. The only exception to this is instances like RAAB, because you you can't open one. So if you're at this index, you see, and if you're at this first A, you see an A on one side and an R on the other, or RAAR. Yeah, you see it R on one side, A on the other, and if you're in this A, you face that same issue. So whenever you add a character, you can just make it a rule to open the right character until you reach a new character. That way you can deal with the issue of an even amount of characters in the middle. But that's basically the solution. So int left is equal to 0, right is equal to 0. And you want to continue this for all characters. So actually we have a cur value that we're looking at, right? And we have our left and right pointers that are opening. So while cur is less than length, and then we can do this to make it easier to access. Okay. What do we need to do? So left is equal to cur minus 1, right is equal to cur plus 1, while right is less than length, and car at right, do car at right minus 1, right plus plus. Then we reach a unique character. So while car at left is double equal to car at right, we want to update this to left minus minus, right plus plus, until we find a value that doesn't match. And let's have a value int max, string longest, and string if, what is the length? Int length of new is equal to yeah, this could be a for loop, honestly. Length of new is right minus left. Right minus left. Is that right? See this example. 0, 1, 2, 3. So it'd be 4 minus -1, because these ones will shift over, right? These are the same. And it will probably go into the outside. So 4 minus -1 is 5. So right minus left minus 1. If length is greater than longest dot length. Longest what? Longest string. Is equal to s dot sub string left plus 1 and right. This is inclusive. This is exclusive. Yeah, pretty simple. Return long string. Again, there's optimizations you can make here. You find a string of 10 characters, then you don't have to really check the rest. Actually, would you? Maybe you would actually, yeah. If you find a length of 20 characters and you have 10 characters left on one side, you don't need to check it because you know that it's either half equal, and even if it's half equal, it'll still be less than 20 characters. You could make some great optimizations here, but you're not building out a full-fledged solution. What they want us to see is if you can make a solution, just anything. Oh yeah, we want to open left and right from index that's valid. So we could do s dot 0, 1, and we could do yeah, so this error was caused by left being out of bounds. While left is greater than 0 and right is less than length, and yeah, okay, so yeah, we could just leave this case and leave this as empty string, and this is empty, fine. Okay, there we go. Now we have proper error handling. Okay, submit. Yeah, so I think I'll call this opening curtains instead of opening window, because I think curtains is more easy to visualize. Oh, okay. Yeah, you know the questions that I made videos for, they're always gonna be ingrained in my mind, because I would do like one takes for these videos. You guys don't know that. Like I think at some point I started editing a little bit, but the majority were just like one take. So if I messed up, I would start from the beginning. Those were like 10-minute videos. So if I start from the beginning every time I mess up, bro, it was a pain. Because I just didn't like editing. That wasn't the point of it. The point of it was to get good at problems. So if you explained one problem 10 times, bro, you're good. You know that problem. I is less than j is less than k, and nums I is less than nums j and nums k. So we want a min, or let's make a value a is less than b is less than c. So you see 1, 2, 3, 4, 5. Let's do this one. This one's like an interesting case. 2, 1, 5. So we could just say A is nothing, B is nothing, C is nothing initially. So first value we see at index 0, it has to be 2. Second value you see, you can replace this 2 with a 1 because it's smaller. So B is null and nums I is less than A. That means update A. There's no reason not to, right? B is null and nums I is greater than A. Update B. A is equal to null. Update A. So in this case, we want to update B to 5. Then we see a 0. So we already know that we found 2 values because we have B. So we can still update A to 0. Why? Because what if we find another triplet like 0, 1, 2, and then 1, 5, 1, 2 wouldn't work out because 1 and 1 are the same. So we can update A to like account for any future triplets because this B value stores the fact that we found 2 and we just need one more value greater than 5. So if A so this is realistically B is null or nums I is less than B because we want to minimize these 2 values. B is null or B is null or this, B is null or this. So nums I is less than A, then just update B. B is null or nums I is less than B. And nums I is greater than A. But this kind of catches that already. Update B. Then we see 4. We should update B. Yeah, because that still holds true. Because we're always just taking the minimum value. So it's not like we replace this 1 and now we can't add 4 here, right? Because even if we see a 1 here, so say we see a 1 here, you would say, hey, we lost our case of 1, 5 because now we have 0, 1. And 1, 1 wouldn't work. But since we have 0, 1, we still have 2 values. We don't care about 1, 5 anymore. We care about the one that has the minimum B value. Because then it gets easier to get C. Because we need our third value to be larger than B. So what do we want to do? We want to minimize A and we want to minimize B. So minimize. And this process holds the state in B. So this holds state of previous, double, single. This whole pace of the previous double. Okay, so I guess you guys know how the general idea works of the problem. So for int I is equal to 0, what if we made it integer and made all these null? Would this throw a fit if I did that? No, it doesn't throw a fit. Java isn't really good with null values, but I've been doing a lot of Kotlin just for Android interviews, so I'm fine with using it. So, for int I is equal to 0, I is less than nums. Actually, we could just do for int I and nums. If A is double equal to null, I, else if A or nums or I is less than A is equal to I, that's our first condition. So these two conditions kind of generate the same thing. Or, so second one, if b is equal to null, or I is less than b, b is equal to I, and we don't have to check, it's already greater than, well actually no, we have to check this condition, which is I is less than b and I is greater than a, because we don't want like 2 2, because we will get 2 2 with this condition. So if you had something like let me throw in an example, 1 1 1 2 1, yeah, you could have a is equal to 1, b is equal to 2. Then we see a 1 again. This doesn't meet this condition, but it meets this condition. And we have a 1 1, which is invalid because we need strictly increasing. So 1 is greater than a. Need for strictly increasing. If b is not equal to null and I is greater than b, return true. And do you know what, we're even going to print it out so you guys can see what the triplet is. Yeah, I guess it should be in increasing order. So a plus b plus c, otherwise return false. Triplet is 1 1 null. Oh, we don't define what c is. So we say c is equal to I. So 1 1 2. Now we look at this example. 1. It should be else if. Alright, there we go. Triplet is 1 2 3 as desired. This one triplet is, there's no triplet. This one triplet is 0 4 6 as desired. Some of them will be like the a value doesn't match. Actually no, it'll always be in the same order because you're only increasing. Triplet is negative 2 1 6. Oh, okay, so we messed up a condition. So 1, a is equal to null, or I is less than a, yeah. B is equal to null, or I is less than b and I is greater than, b is equal to null and I is greater than a. So that's the first condition. So we can't just like set any value to b. That's wrong. Or this one, this is the condition that was wrong. So let's start making our code a little bit more readable. So or I is less than b and I is greater than a. So yeah, even when b is null, we need to check this condition, which is I is greater than a. That's breaking it. We can check this test case again. Yeah, so before I was checking b is null, but that's fine. Yeah, so the idea is even if b is null, the value still has to be greater than the first value that we looked at. Forgot to add that condition. Now it should work, yep. Let's see the fast solution. Oh, they set integer.max value to the first and second because you're always trying to minimize those. So if you start with max value, it's just as effective. Alright, submit. Great, I think we're gonna finish on time because I gotta leave somewhere soon. Ah, dude. What is this? Count and say. Alright, after this I'm gonna take a break, do linked list, trees, backtracking, not sorting and searching. Dynamic programming I will do though. This is pretty good, and I'll do that too. Yeah, we spot his design, honestly. Run length encoding. Sure, we could do string. You gonna return string anyways? It's kind of like a left-right pointer approach where we have a count. So if Add current block to string. You always end off with having a value that wasn't added. You always have a value that wasn't added, so return output. The system.out.print line start. Move that after the function. Yeah, so initially start is 1. And then every time we call the function, let's see what it looks like. And then return it. Okay, so this is just like counting blocks. Counting block, count a block, count a block. Integer.parseInt count. What is it? Integer to string Java. To string.value of, oh man. String.value, okay, so parseInt is the other way around. Go to string to number. String.value of again. Okay, 1, case 2, okay, 1, 1, 1, 2 1s, 1, 2, and 1, 1. Okay, looks good. So this is, yeah, it's a pretty easy problem, just blocks, you gotta count. Pretty slow. I'm sure people found like a nice, fast way to do it. No, they did not. They did a recursive formula. Return RLE counted say of n minus 1. Yeah, it's a recursive formula. And this is the same thing. Okay, and yeah, you can see how it works, but they're using string buffer. So strings are immutable, so that's why mine's is so slow, because it's reallocating space every time you reassign it. That's why you use like string builder or string buffer. Where was I? Why is this not updated? Okay, I think that's a good place to end the stream for the first block. I gotta go like somewhere 120 anyways, and let's just add this to submission list and we should be good. 1, 2, 3, 4, 5, 6, 7, and a resume critique. Not bad for the first part. We'll do linked list and trees for the next part, and the last part will be dynamic programming and design. See you guys.